Hello, third graders. Welcome to the first trimester review. Let's go ahead and review a few of the topics that we learned in the last few months. Okay, so question 1, this table shows how many cars are in 3 garages. And if this box represents 2 cars, and which answer choice correctly represents the number of cars in garage 2. So in garage 2 there are 7. Okay, there's 7 in garage 2. So if one of these blocks is 2 cars, then what is there? So this would be B, right? This would be 2, 4, 6, 7, because we're counting by 2. So 2, 4, 6, 7. We're looking at B for this question. Okay, question number 2. The table shows how many cars are in 3 garages, and if each car is able to hold each garage is able to hold 16 cars, how many more cars could this dealership be able to store? Okay, so I'll make this a little bit bigger. So there's 15 and 7 and 8, and if they can all go to 16, then how much more would that end up fitting? Okay, so plus what equals 16? Plus what equals 16? Plus what equals 16? Okay, so this garage could hold 1 more. This garage could hold 9 more. And this one could hold 8 more. Okay, so now I'm going to add up the new potential capacity that could fit in these garages. And that would be 18. Okay, so we could potentially buy 18 more cars to fit in these 3 garages. Alright, question 3. Kendra has displayed all of her 36 Pokemon characters. What are all of the other ways she could arrange her Pokemon? So if there's 36, we want to think of what dimensions would make a rectangle. So if we have 3 by 12 here already, we could line them all up in a single row, right? 1 row of 36. That would be this one. What else could we do? We could do 2 rows. 2 times 18 would be 36. What else? So we have 3 times 12 already. What about 4 times something? Could we do 4 times something? Yeah, about 4 times 9. 5 times something, not quite. What about 6 times 6? 6 rows of 6 columns. That would be another way to do it. So we have 1 times 36, 2 times 18, 4 times 9, and 6 times 6. Okay, so here we have to remember, what is product? What is product? Well, product is multiplication, right? So the product of any number and 0 is 0, right? 5 times 0 would be 0. Now we have to look at all of the true equations. 5 divided one way, so there's only one person that has to share 5 pieces of candy. Okay, that's not correct. So 5 over 1 would actually equal 5, not 1. So cross that one out. 0 over 7 equals 0. That's true. 9 over 9. Okay, that's a whole, right? 9 potential equal divisions, and they're all filled up. That's a whole pizza. How about this one? 2 over 1. Okay, so let's say a ball is divided equally. There's only one opening, right? There's only one way to divide it. You don't cut a ball into pieces. Now there's 2 of these. 2 over 1 is 2. That one is also true. Okay, Jim has 15 markers. He puts an equal number of markers in each of the 5 cups. So how could we do this? All right, so we could make 2, 3, 4, 5 cups. And let's start to distribute these 15 markers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many fits in each cup? 3. 3 markers. Okay, write division equation to represent the repeated subtraction that's happening here. So if we have 24 take away 6, that makes 18. 18 take away 6 makes 12. 12 take away 6 is 6. 6 takes away 6 is 0. Okay, so if we took away 6, how many times? Well, it happened 1, 2, 3, and a 4th time before we used up all of those units. Okay, so what would that possibly be? Well, 24 divided by 6 would be 4. Okay, we had 24. Repeated multiplication is another way we can use to understand division. 24 divided by 6 makes 4. We had to do it 4 times. What fraction represents the red circles in the group? Okay, let's identify those red ones first. So that's a red one, and that's a red one as well. How many were there total, though? Let's look at the total circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that'd be our denominator. So of the 12, 1, 2 are red. So that'd be 2 over 12. Okay, complete the whole number and the fraction greater than 1. And we're thinking of one carton as being 1. So how many cartons do we have? 1, 2, 3. So we have 3 whole cartons. But if we think about it as far as like eggs go, how many eggs are in each carton? So a carton is divided in 12 equal egg holders. So how many total egg holders, how many total eggs do we have here? Okay, so out of a capacity of 12, or divided 12 ways is the denominator, we actually have 36 total eggs here, right? And that's what we would be looking for. How about this one? Looks like some Minecraft cars here. So complete the whole number in fraction greater than 1, like we just did, on how many sets of tires. So one car has 1 set of tires in each, and a car uses 4 tires. Okay, so how many sets of tires are going to be used here? 1, 2, 3, 4, 5, 6, 7, because there's 7 cars. And what would that fraction be? Remember, a whole set is out of 4 tires, but we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on until we count all of the actual tires on all 7 cars. So we'd have 28 over 4 is the actual fraction we're looking for. Okay, great job, everybody, and I'll see you in the next video.